Hi, I'm Steve Lasker. I'm a program manager architect at Azure. I focus on our container registries, which is the ACR for private registries for users to use, as well as MCR for serving Microsoft content globally. Microsoft is a software company, not just a cloud. So we actually have an interesting problem on how we serve public content. Because as a software company, we feel it's important for us to own the delivery of our content and make it kind of available on Docker Hub, but you should be able to acquire it from us directly. As well as how do we serve that to our users? And obviously we have a pretty large base. ACR is in approximately 50 regions worldwide, and we run about we run 5 clouds between the public cloud in US and US, Europe and parts of Asia, and then China, and then some air-gapped government clouds as well. So it's a pretty robust space. What I want to talk to you about today is how that registry infrastructure can be used for all kinds of package management. And there's a bit of a shift that's kind of happened in the industry. So if we think of where people store their content today, what does today mean? Yesterday, right? So it's, we store stuff in Git, that's our source. We build, and we used to take the output of the binaries and we'd put them on some share of some sort, and then we would deploy that. And that was largely humans involved, and we were working on getting automation going. The advent of CI/CD and automation and continuous delivery and so forth, and certainly containers enable this, is the idea that they can be auto-scaling, self-healing, so on and so forth, where a deployment is not just an automation of what a human does. It's actually like, I'm automatically scaling something up. I'm automatically pulling and deploying that content. And at the same token, we have all of these requirements that are coming in around security and reliability. So that's where container registries became an interesting solution to how these deployments were managed and how that infrastructure can be leveraged. So the talk is kind of interesting. It's, I'm not exactly sure the attendees that are here, because it probably breaks up into at least 2 camps, if not more. There's artifact authors that are building a thing. It might be WASM, it might be the Singularity team when we talk to them, OPA, or something yet we don't know about, right? That's the beauty of this. If you're building a new thing, do you want to build a service to serve your thing as well? Or can you just focus on building the thing that you're trying to enable? And this is how this all started with the OCI Artifacts work, is we were trying to do this for Helm by adding Helm support in ACR. And as we were doing that, Singularity, this other optimized high-performance computing service, was looking for how do they store their content. And then we were asked about CNABs. And then there was, what was the other one? I can't remember the other ones at the time, but basically before we could even get a specialized Helm CLI out, there was more and more and more package types that we were asked to host. Like, okay, we need a better scalable solution for this. From a consumer's perspective, how many of these package managers does somebody need to configure and manage? And how many have the capabilities that they need across all of them? So this is kind of how we went about it. We said, all right, container registries know how to serve content. These container images, they're pretty big. They're optimized. It's not just like this monstrous VM that the infrastructure used to be. They can serve all kinds of package types. So what we kind of said was like, how about we don't have to build yet another storage solution? So no more YASs. The idea is these container registries can become artifact registries, and we can store and serve all of that new content types out of it. Now, our engineering team wanted to go after some of the existing ones, and I've always kind of had this thought of they ain't broke, don't fix it. Well, it turns out some of them were broke. Most package managers out there are underfunded and struggling in various ways, even for the public registry, much less a private registry. So, and every one of our customers are trying to say, look, it's great, this public content. I want my private ownership of it as well. So we are transitioning packages.microsoft.com to run on the ACR infrastructure for exactly that reason. And we've done other works and prototypes around PyPy and Maven and NPM and so forth on how you can leverage this infrastructure. But just to kind of put a reality check on some of this stuff, it's always interesting to want to build yet another package manager. It turns out it's fairly difficult, right? It starts off pretty simple. It's just some REST API and some storage. What's the big deal? Oh, wait, I probably want to authenticate for who pushes. Probably want to do some caching. Who's going to support this thing? Either the product that I make out that somebody's going to call, or if I'm running it as a PaaS service in a cloud, who's going to support it? And then it gets into things like, how do you support signing and all the other features that keep on coming. And the requirements just are never ending of the things that you need to run one of these storage services. It takes about 10 engineers, probably a little less depending, probably a lot more depending, right? So we have a much larger team because the volume of transactions and clouds and regions and capabilities that we run, that's just for ACR. Imagine if we had to run a Singularity service, a WASM service, an SBOM service, right? Those start adding up, and those are resources that are duplicating largely the same features. And if you think about what it takes, if you want to build one of these services and you want one of the clouds to run these services, well, somebody's got to bring a big bag of cash to get us to run them because they're not cheap to run. Are we going to charge customers? These are all lost leader type of services. So it's not really an easy thing to manage, and certainly for all the private registries. And there's a lot of requirements on these. And these are not the things that I'm guessing most of you are thinking about that want to go build yet another package manager. It needs to be in the location you're being deployed, right? The clouds, there are multiple cloud locations. You have, even on-prem, you have multiple on-prem locations that you want that content to be local. It needs to be replicated across all of those locations, including on-prem. It needs to be available in a private network. That has taken us years to get right, and I think we still have more work to do. So private networking is certainly in a PaaS service is not an easy task to take on. Authorization, all the different authorization schemes that match your production environments, lifecycle management, diagnostics, data encryption at rest. I mean, this is just some of the features that we support in ACR. I didn't want to make this as a feature map for a heat map as a competitor, because all of the clouds support a range of these kind of services, and there's probably some missing for us that we have to add, and for other clouds there's probably something missing that they have to add. These are all pretty difficult capabilities to run on every one of those storage services. So that kind of brings us back to how we did the OCI artifacts and have OCI registry as storage as a project to enable that capability. So I wanted to kind of bubble up a little bit, as we're thinking, like, what is that infrastructure of how registries work and how can it be leveraged? And if you look at how container images are run, this is kind of interesting when you compare it to, say, a VM or some other components. I have a client, the Docker client on the left, well, left, right, whatever, the side that says Docker, and then the registry is on the other side. And there's that REST endpoint, there's storage, and there's this concept of manifests and blobs. So a client says, hey, I want this net monitor artifact. I want version 1. And the endpoint that I'm going to connect to is this Wabbit Networks Azure ACR.io. That's the registry endpoint. The client says, hey, I want this thing. And the server goes like, okay, let me give you a manifest of that thing. It's not a single blob, because it might be large. I might want to break up and stream multiple streams of the container images. They're in layers. I might bring multiples to the client. They might be multiple files, even in something small like a Helm chart. The client says, great, I got this manifest, a list of things. Do I have any things already pre-cached on the machine? And then it says, well, I don't have these IDs. It doesn't say I don't have these URLs. It says I don't have these IDs. And it goes back and asks the registry, hey, can you give me some URLs for these IDs? So then URLs are returned. And the interesting thing of the way registries work is the URLs are somewhat dynamic. The registry endpoint is fixed, but the data endpoint can vary. It might be on a CDN. It might be from a particular region. It might be in China, might be Europe, might be US, might be on-prem. The idea is you can dynamically give different data endpoints depending on the configuration and the locality. So this handshake is going back and forth, and you eventually get all of the content you need based on that manifest. And then you could say, hey, I have the thing, continue on your path. Now, if you look a little bit deeper, that manifest is just some data, right? There's a collection of blobs. They're stored as these content addressable descriptors, which basically says what is the type, what is the size for comparisons, and the unique identifier, the digest. In container images, there's this other config object, and then there's a media type that says, what kind of manifest this is. This is the one that says this is a container image. If I want to be a Helm chart, I can say this is a Helm chart in the second one under the config media type. That's how we do this today in the OCI Artifacts approach. What we're shifting to is, and I'll start doing some more demos of this in a minute, is we want to take this generalized format that have been used for a couple of years now, and even longer than that. There was many people stuffing stuff in registries that weren't container images. They just made it look like a container image. Just like we used to send emails as a zip file with attachments, even though they were something else, because that's what was allowed. So when that client finally gets it, just like I said, it's just a blob URL, but it's a pretty long one. No human wants to type that. It's a handshake that has things like tokens and other stuff in it. So what we wanted to do was shift this now to be artifact manifest, because we see a new set of scenarios for supply chains. So we want to say, look, layers, that's a container image concept. They're really just blobs. The config was also unique to a container image, not unique, but it wasn't required in most cases. Container image made a use of it. So we're just going to say the config is actually just one of the blobs. And the blob storage is blob storage, and it may or may not have a config as one of the blobs that are in it. But the concept that we're also adding is the ability to store linkages between those with this graph. So now I'm transitioning from what we did with, storm alert of some sort. So now I'm going to transition from what we did with OCI images and OCI artifacts, rather, we can store singular things. I want to show not only that, but how we can store a graph of objects such as signatures and SBOMs. So got it wrapped up in this environment variable for a container image. And this is running in ACR today in a South Central US region. So we'll start off with, of course, a Docker build and Docker push. So that'll be what I have locally. Not locally, that's what I'm building in this registry, and life is good. And I'll show the tags that are there. And we can see I literally only have one tag, the v1 of that container image. Now, I want to send up something I want to call a reg doc. It's basically just going to be two files. That's going to be a README, for the home page, and then if I want to click on it and get more details, there'll be a more details markdown file. With ORAS today, so OCI Registry of Storage is the client, I can push this artifact, which if I just echo artifact, it's just a fully qualified name. I'm going to say I want to push another individual object, the net monitor. I'm going to create another regdoc tag. And if you look close, is the manifest config. This is effectively saying this is the file extension. On your disk, you create a .foo, and that's how you know it's a type. The file system doesn't care. It just has a way to identify that. That's the same thing we do here. And then I'm just passing up these two files, and I'm just saying, by the way, these are markdown files from a media type. And if I want to download those, I can say, or as pull at artifact, and give me all of the media types. And now I've got those two files on my machine. So now I'm leveraging that registry to store not just one file, blob, but multiple files. Those two markdown files could have been multiple tar files, right? Which is the idea is I'm using that blobs collection. Now, that was great for individual objects, right? I can have my registry full of individual files. But the thing that we saw when we were developing Notary v2 is we needed to be able to store additional files in a registry that are disconnected. I don't want to pull the container image down to validate the signature, because now I just pulled evil content in as a Trojan horse attack just to validate the signature. I want to get the signature as a torn off object. So we implemented this concept called reference types. So what I'm going to do now is I'm going to use a newer version of the ORA CLI, and I'm going to push to the repository. I'm not going to give it a tag. I'm just saying go to the netmonitor repository, set the type to be a regdoc, just again, that file extension, and create a reference to the subject netmonitor v1. And then again, I'm just going to add those two files. So now I've uploaded those. And if we look at the listings in the registry, we're going to see I still have those two, but that regdoc:-v1 is that original one. I just added another thing to the v1 tag. So if I list the manifests, right, that's the defining of what is in a registry, what we'll see is here's the ORAS artifact manifest. Here's the regdoc that we just sent up. Here's the regdoc that we sent with a tag. And then here's our container image, right? So we have that content in the registry, but what we were able to do is set it up as a tree. There's a reference now between those. So if we look, and it looks like that didn't clear up my previous examples, so that's fine. If we look at what got pushed to the registry for netmonitor v1, here's the regdoc, and then that's the digest, the unique identifier for that content. Here is stealing my demo of what I'm going to do next is there's a signature that's got a digest and an SBOM that has a digest. And by the way, the SBOM is also signed. Notice the indentation here. So if I want to show how I built that, since I didn't actually build it up and I brought it up before, let's first do one thing. So I want to delete that individual artifact that had the regdocs, right? The one that I pushed using the OCI Artifacts approach. And if I look at the tags now, we'll see there's only going to be one because everything's hanging off that v1 tag. And just to show what I had done here, so if I create a signature, and I'm just not going to get into the notation stuff right now, I just want to show here's a file, and I can push that signature to the registry as a signature example. This would say notary v2, or what we'll do is an SBOM in a second. And if I view that tree, we're going to start to see that is those examples come through. Now, in this case, because you'll notice that this didn't expand any further because the signature, it realized it's the same digest, it's the same content that I pushed previously, so there isn't a duplicate there. And I can continue to go with SBOMs. Here, I'm just going to fake out an SBOM. I'll push it to the registry, right? I'm again setting the subject to the netmonitor v1 image, and then sending up the file as a JSON type. And if I want to sign that SBOM, I get the digest of it, because we always sign digests. I'll create fake SBOM. I just stick the digest in there as part of the content. And I'm going to push that SBOM to the registry. Again, this is signature example, right? So I'm putting a signature of the SBOM to that repo. And if I view the graph, we'll see, again, that rich graph we've been building up. Now, the idea of content hanging off a single tag, right? We want to think about that content as a collection. If I look at a directory on my local computer, I'm going to see ls, so I'm going to see a bunch of files. I don't see the attributes of those files, because this is the list of content that I want to reason about. If I want to see the attributes, I can explicitly ask for it. There's a pivot there for the attributes on those files. That's the same way we think about with these ORAS artifact reference types. Now, what makes this super interesting is if I want to copy the content from one registry to another or one repo to another within the same registry, right? If I want to promote that content, do I need to go back and find every one of those individual APIs? So I need to find the SPDX tool to copy SBOMs over. Do I need to find the notation CLI to copy the signatures over, or some scan results or something else? If I'm copying files from one directory to another, I don't use the PowerPoint and the VS Code file. I go and just use the file APIs. So that's one of the interesting things, where if I have this concept of reference types in a registry, it starts to act like a more robust file system, and I can use generic APIs on it. So if I look, nothing up my sleeves, there's nothing in the private registry. What I can do is do something like an ORES copy API. And I'm going to copy the content from registry 1 to registry 2. And now if I look what's in registry 2, I can see there's a net monitor image. Am I out of time, Wolf?
Yep.
Okay.
Unfortunately. If you want to take questions, you have like 3 minutes now.
I'll bubble up and wrap up. So the idea is we want to be able to support the promotion across registries. Registries are reference types. Every cloud has one. Do we really want to build up yet another one? Registries are not complete. This is where you can come in if you're considering building a package manager. Instead of building a new one, how about we extend the infrastructure that's already there? So that's kind of the pitch here. Let's continue to add to the capabilities instead of keep on building incomplete registries. So with that, I'll stop and take questions. It's always fun to dig into demos and get carried away.
Awesome. Thanks for your talk. Let's see if there are any questions.
I don't know which of these are current, so.
I see someone.
Previous talk here. Okay. So with that, I don't know. Where
I'm not
it's
seeing
always
any
interesting coming to a packaging conference and say, you guys shouldn't build any more package managers. Let's go build on one. There's plenty of work to be done. The question, like I said, is do we want to build from scratch, or do we want to extend this pretty rich infrastructure that's there? So that was kind of the idea.
Yeah, I think it's great. I love this idea.